Welcome to EDU World Space.
Hi everybody. So we need to determine the damping constant and the spring constant in this. And we're given the mass or the weight of the railroad car, and here we can find the mass equals weight times gravity. And we're just going to keep this into pounds per feet. And you can do this, especially if your problem uses pounds, then you can keep it with pounds unless your professor says otherwise. And gravity with feet is 32.2. It's not as pretty, you do not have to memorize that. But this problem, we're just going to do it this way, and hopefully you're not cringing. It's definitely an American measurement here. But that is the mass that we find for this. And we need to find the damp frequency. And we have the omega here equals 2 pi 0.41 seconds equals 15.325 radians per second. Okay? So we have those periods. Now we can start with A. Okay? So A, we have X equals X naught E minus C for the critical damping, 2M the time times sine omega E T plus phi. Okay, and this right here is proof why you should write your T's and your pluses a tad bit different from each other. So here we're going to look at x1 equals x naught. So, and then for that, it's going to be E minus C 2M T1. And, okay. And so now we have, so this is the first peak at, basically is at x initial. And the x initial, there's not going to be a sign, so that's why you don't have a sign, okay? And now we have the second peak here. And because here we're doing like that, so there's nothing here. We don't have to worry about it. Your sign's not going to be there due to the trig function, okay? So your second peak, we're going to have your T2 is going to equal T1 plus T. So here we have X2 is going to equal, because we're still using this one right here. So X2 is going to equal X naught times E minus C2M and T1 plus T. Okay? And now we're just going to put X2 on top of X1. So we have X naught, E minus C, 2M, T1 plus TB, and over E minus C, that is 2M, T1. And with this, we end up with, it looks like we end up with E minus C, 2M. It's going to be minus, so it's going to have the TB left over. Okay? And now we're going to ln on each side. So we're going to do ln. So we have ln x squared divided by x1. It's going to equal ln of your E minus C 2M UTB. And with this, you're still going to have your ln here, x2, x1, equals negative C2m times B. And with that, so that looks pretty good. And now we can add in what we have. So we have 0.12 inches here, and 0.5 inches here, equals C divided by 29.31. Oops. My bad. So 931.67 pounds times squared feet. So make sure you don't get your pounds mixed up with a 1. That's kind of more common than you think. Times 0.41 seconds. Okay? And we're going to keep going down. We want C by itself. And to do that, we're just going to have C equals ln 0.24, because we simplified this to this, okay? Times your 2 times 931.67 divided by 0.41. And this, your C is going to be 6485.9 pounds times second divided by feet. Okay, and you can make this smaller until kilopounds, and that's going to be 6.49 kilopounds per second. Okay, and that's your answer for A. And now I've got to do for B. And B, we have your omega, your frequency here, times Km minus C2m squared, okay? And for this, we're just going to plug in all the information that we had above in here. So at the beginning, we had this number, 15.325 radians per second, squared equals K, and we're going to need the K, but we're just going to write this out, 931.61 minus your 6 point, or let's just do this the long way, 64859.9 divided by 2 times 931.67. We're going to square this, and we have your 234.856 equals K, 2931.61. I'm not writing the units right now just because it takes up too much space, to be honest. But you can if you like, because this is going to be pounds, second, feet, pounds, second, feet, pounds, second, feet. There we go. But I'm not going to finish writing this just because, you know, whatever. So 931.61 times 246.972 equals 230. So this whole thing's going to equal 230 kilopounds per feet. Okay? And that's your answer for B, okay, guys? So thank you.